This is the part 2 of the video series on problems on exponents and powers. And in this first problem, express using exponential notation. So we have two numbers and we have to write in exponential notation. So in such problems, you always have to do prime factorization, right? So if this is 729 and if we have to do 729, prime factorization of 729, though clearly since the last digit in this number is 9, so this number cannot be divided by 2. The next prime number is 3. In order to check whether any number is divisible by 3 or not, what we do is we add all the digits. So this is 9 plus 2 is 11 plus 7 is 18. 18 is divisible by 3, right? 7 plus 2 plus 9 is 18. And 18 is clearly divisible by 3 because if you divide this by 3 you get 6. So yes, this number is divisible by 3, and let's do the prime factorization now. So 729 this is 3, 2, 6, 4 and 330, 243. Now further divide this, you get 81. You further divide this, we get 27. If you further divide this, we get 9, 3 and 3. So if you write 729 using exponential notation, then that will be, so this is 1, 2, 3, 4, 5 and 6. We have to multiply 3 6 times. It means this is 3 raised to the power of 6, right? So 729 can be written in this form. Now next one is 3125, 3125. Now clearly the last digit is 5, so it cannot be divided by 2. Now first check for 3. The next prime number is 3. So add up all the digits. 3 plus 1 is 4, plus 2 is 6, plus 5 is 11. Clearly 11 is not divisible by 3, therefore this number is not divisible by 3. Next prime number is 5. Yes, clearly this number will be divisible by 5 because it contains 5 as the last digit in this number. So 3125. Okay, let me remove this. Let's do the prime factorization. So 5, 6, 30 and 5, 2, 5. Then if you divide this, you get 125. If you divide this, you get 25. If you divide this, you get 5, and you get this 1. Okay, so 1, 2, 3, 4 and 5. So this 3125 can be written as 5 into 5 into 5 into 5 into 5. That is 5 raised to the power of 5. So this is the exponential notation of 3125. In this one, which is greater? 100 raised to the power of 2 or 2 raised to the power of 100? Okay, now what you will do? This one can be written as, let's solve for this one A. This 100 raised to the power of 2 can be written as 100 into 100, right? And this gives you what? This gives you 10,000. This much we know. Now, what for 2 raised to the power of 100? Now 2 raised to the power of 100, this is not possible for us to write this 2 times 2 into 2 into 2 into 2 100 times, and then you have to find the multiplication of, every time you'll have to multiply and you have to do this for 100 times. Is that possible? No, that is not possible. So what to do? Because we have to tell the answer which one is greater. Here's a trick and here's a way to solve this. So this is what I'm writing this here. Okay, so let me copy this here. Control X and Control V. Okay, this is what 2 raised to power 100. Now this is 2 into 2 into 2 into 2 into 2, and we will go on in this way. Hundred times, right? We have to write 200 times and we have to multiply it. That's for sure. So from here to here, how many 2's we have? We have 100 2's, right? Okay, we have written this form. Now, if we group, this is 2 into 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. If we group the multiplication of 2's, if we take 10 2's and multiply them together and we make it one group. So clearly if we have 100 2's and if we are grouping multiplication of 10 2's together, so in that way we'll have such groups. If I denote this as like this is our group of the multiplication of 10 2's, we will have how many such groups? We will have 10 such groups. And why 10 such groups? If we group the multiplication of 10 2's together, so in this one we have 10, in another one we'll have 10, in another one we'll have 10. So clearly we'll have such 10 total groups, right? If you divide 100 by 10, you'll get what? You'll get 10. So if total is 100 2's and in each group we are putting 10 2's, so how many such groups you'll have? You'll have 10 such groups, right? That's what we are doing here. So imagine this is the first group, the same group is this one, 2, the same group is third one, and in this way we are actually making 10 groups. In each group we have 10 2's multiplied together, right? So suppose this is the last group. Suppose this is the last group. So 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So clearly this one will be the 100th 2 and this one will be the first 2. We have grouped the multiplication of 10 2's together. Now look here, if you find the value of this first group, that is you are multiplying 2 10 times, if you find its value will be, this is the 10th group, let me denote this, this is the 10th group and this is the first group, this is the second group. The value of first group will be 1024. If you multiply 2 10 times, you will get 1024. In the same way, the value of the second group will be 1024. The value of each group contains what? Multiplication of 10 2's. So the value of each group is 1024. Now focus on only the first group and the second group. The first group and the second group. This is what? 1024. And this is what? This is also 1024. Multiply these two groups together, right? Multiply these two values. So you get 1024 times 1024. This gives you 16. This gives you 9. This 0 and 4. 8, 4, 0, 2. 0, 0, 0 and 0. Then you get 4, 2, 0 and 1. This is 6. This is 17. This is 5. This is 8. This is 4. This is 0. This is 1. Okay. So what do we get? Let me write it here. So we get this number. We get what? So this is 100,000, 10,000. We get 10,48,576. This is what? This is 10,000. This is what? This is 10,48,576, and that too when we have just multiplied two groups, only two groups, right? One group is multiplication of 10 twos together, and there are 8 such more groups. So clearly, when we are simply multiplying only two groups, we are getting 10,48,576. It's much bigger value than 10,000. So which one is greater? 2 raised to the power of 100 is greater than 100 raised to the power of 2. Okay, there is one another way to look at this problem, and you can actually tell without even calculating this multiplication. And let me tell you that, because we should discuss each and everything that we can. Okay, let me skip this. Okay, look at this first group 1024, second group 1024. Even if it was not 1024, if it were only 1000, just imagine that if it were not 1024 but only 1000, right? And clearly, and why we are assuming this? Because 1024 is clearly greater than 1000, right? 1024 is clearly greater than 1000. So what we are assuming, that even if it were not 1024 but only 1000, and the same thing, if we apply the same thing here also, if it were not 1024 but only 1000, so the multiplication of these thousands, these two thousands, would be what? Would be 1, and how many zeros? 6 zeros. 1, 2, 3, 4, 5 and 6. So you get 10 lakh. You get 10 lakh. Can you see that? We can quickly tell again. So this, even when we are assuming that it's not 1024 but only 1000, and if we multiply these 10,000s together, then we would get 10 lakh. Then clearly this 10 lakh is greater than 10,000, right? So you can see that we saved our time by not by avoiding the calculation of 1024 times 1024. But in examination you will have to show this, right? And yes, you can also show this step also. You can mention each and everything, that by using this method or this approach, we can prove that this is actually greater than 2 raised to the power of 100 is greater than 100 raised to the power of 2. That's the beauty of mathematics. Okay, isn't mathematics fun, right? It's a fun, right? Now look at this one. This is 2 raised to the power of 10 and 10 raised to the power of 2. Now clearly we have, just in this part only, we have calculated the value of 2 raised to the power of 10, and that is 1024. So 2 raised to the power of 10 is 1024, and this 10 raised to the power of 2 can be written as 10 times 10, that is 100. So clearly 1024 is greater than 100. So 2 raised to the power of 10 is greater than 10 raised to the power of 2, right? And in this one, 2 raised to the power of 100 was greater than 100 raised to the power of 2. In this third problem, we have compare the following numbers. This is 2.7 into 10 raised to the power of 12 and 1.5 into 10 raised to the power of 8. So let's solve for this first one. So 2.7 times 10 raised to the power of 12, and this is 1.5 times 10 raised to the power of 8. Okay, tell me one thing. Can I write this number as 2.7 into 10 into 10 raised to the power of 11? What I have done is I have simply taken out 1/10 out of this. Why? Let me show you, expanded. This is 10 raised to the power of 12. So if this is 10 raised to the power of 12, it means that 10 times 10 times 10, 3. This is 4 times, 5 times, 6 times, 7 times, 8, 9, 10, then 11, then 12. What I'm doing is I want to separate this 110 out of this. So let's keep this 10 as it is, then multiplied by how many tens are left? Clearly, multiplication of 11 tens are left. So that's simple. We'll write this 10 raised to the power of 11, and that's what we have done here. And why we have done this? See here, 2.7 multiplied by 10, what this will give us? This will give us 27. We did this just to get rid of this decimal point. So 27 into 10 raised to the power of 11, right? Same thing can we do here? We can write it as 1.5 into 10 raised to the power of 7. So this gives us 15, 10 raised to the power of 7. Still, it's difficult to compare because we cannot, right? It will be a very, very long calculation if we go on multiplying 10, 11 times and then doing this. So what's the way? The same thing what we have done here, let's apply a little more mind here. Can I write this number, this one only? Focus on this one now, only this one. Can I write this number as 27 times, I'm taking out now 1 10, then second 10, then third 10, then fourth 10. I'm taking out 4 tens out of this one. So how many tens are left? Clearly 10 raised to the power of 7. How many tens are left? 10 raised to the power of 7. Why? Because I have taken out 1, 2, 3 and 4 tens out of this one, right? So if you're wondering why we have done that, it will be clear to you. Okay, so what does it become now? This is 20, if you multiply this together, this is actually 27 times 1, 2, 3, 4, so 10,000 times 10 raised to the power of 7. This gives you 22, 7 and 4 zeros, 1, 2, 3, 4 and 10 raised to the power of 7. This is what? This is 2,70,000 into 10 raised to the power of 7. Now here's the thing. Focus on this number and focus on this number. Can you find something common? You'll say yes, this is common, right? What does that mean? It means that this number is 2,70,000 into 10 raised to the power of 7. This is 15 into 10 raised to the power of 7. Again, 2,70,000 into 10 raised to the power of 7 and 15 into 10 raised to the power of 7. It's just like asking 100 raised to the time into 10 raised to the power of 7 and 1 into 10 raised to the power of 7. This is common, this is common. Clearly, we are going to compare these two numbers only, right? Which one is greater? 100 is greater than 1. Here, which one is greater? You will say 2,70,000 is much greater than 15. So, this number is actually greater than this number. So, finally, 2.7 is 2.7 times 10 raised to the power of 12 is actually greater than 1.5 times 10 raised to the power of 8. Wasn't it fun? Right? And that's very simple. What all you have to do is just focus that what can we do, how can we reduce these numbers in a way that we can compare them without doing a lot of calculations. That's really very important. So you can see here, that's similarly we are going to solve for this one, the B one. Let's do this. In this B1, we have 4 into 10 raised to power 14, right? And this is 3 into 10 raised to power 17, right? Now just focus on this one. Why? Because here 10 is raised to the greater power. This is 17 and this is 14. So just we'll focus on this one. What I'm going to do is I'm going to take out 3 tens from out of here so that it finally becomes 10 raised to the power of 14, same as this one. So this is 3. I'm going to take out 3 tens out of this. So 10 times 10 times 10. So since I have taken out 3, it's left is 10 raised to the power of 14, right? So this is 3. If you multiply this is 3 times 1000 into 10 raised to the power of 14. This gives you 3000 into 10 raised to the power of 14. So just what we have done in the A part, same thing we are going to do in this one, right? This is 10 raised to the power of 14. This is also 10 raised to the power of 14. Now clearly we only have to compare 4 and 3000. Which one is greater? Clearly 3000 is greater. It's greater than 4. So this number, that is 3 into 10 raised to the power of 17, is greater than 4 into 10 raised to the power of 14.